Okay, so if I want you to solve for r from this right here, PV equals nRT, how would one do that? Shout it out. Divide by what? N and T on this side, divide by N and T on this side. If you do one thing to one side of the equation, you have to do the exact same thing to the other, allowing for us to cancel out N and T, isolating R, right? So I can rewrite this in a different way. R is equal to this, PV over NT. Most of us probably are like, duh, Miss Enlow, we know how to do this. Okay, let's try one more. Of these three, 1, 2, or 3, which one do you guys want to do? 3? Okay, this one looks kind of cool. Okay, I need to cancel. There we go. Okay, so I want to solve for x here. Can I combine these? Can I combine these like terms? Right, I can. How? Does the 2 change? No. Does the x squared change in addition with this x? Yes, right? So that's going to be kind of combining like terms. So it'd be 2x cubed is equal to 180. And then if I want to isolate that further, I would just divide by 2 on both sides. So x cubed, which remains on this side, on the left side, equals 90. And then I would do what? Or cube root it, right? Because it's a cube. So then I would cube root that. So x is equal to whatever the cube root of 90 is. Okay, so I could do that calculation on my calculator, but you can see that's something that you might be expected to do later on. But all of this stuff is just rearranging formulas, solving for something that's asked to be, right? We're not going to hit as much into this detail today, but we're going to try to use our units and solve for different givens that are questions that were asked for. So I'm going to start with that, okay? So these are things we will eventually be asked to do, and I have some other ones down here that we might solve for later. Okay, so fractional dimensional analysis. So fractions or factor label method is something that you may have read about in Reading Guide 3 chapter. Looking at this right here, does any of this look familiar? Conversion factors, etc. Shake your head yes or no for me. Something should ring a bell, okay? And this is at this point, since we've already looked at Reading Guide 3, I gave you your Reading Guide 3's back. You can take notes on Reading Guide 3. If you find that something's like, oh man, this is really familiar to me, take just a couple extra notes on Reading Guide 3, or take a couple notes that you need. I'm not going to expect you to write down every bit of this, because some of this is going to be the second or third time you've seen this. So I'm really hoping it's starting to sink in. So looking at the first part, dimensional analysis, factor label method. They're just the names that we call chemistry math. It's just a name for it. So if I ever say dimensional analysis, I'm not talking about like, you know, some crazy math. I'm just talking about chemistry math. So whenever we use dimensional analysis, we always write units. You guys probably saw on your problem sets 3 that are 3As that I put back on your desk. I said write units, write units, write units. If you did problem set 3A, I gave you 10 out of 10. I gave you 100. It was a freebie. I went through and checked that you had sig figs and units. I made some extra notes, but I didn't take off for anything unless you just didn't do a problem. So that was just me trying to show you what I expect for problem sets and what I expect for solving problems like this. So anytime that we have dimensional analysis, we always use units, because the goal is literally to change something from, let's say, miles to feet or miles to kilometers. But I need to do that. I need to be able to cancel out those miles. I don't want miles anymore. I need to cancel those units. So you have to be able to put units down all the time. And the way we cancel units, the tool we use is called a conversion factor. The conversion factors are usually fractions made from things that are equivalent to one another. For example, one that we all should be familiar with, let's go 1 foot is equal to 12 inches. Normally we would not use feet or inches here, but I'm just going to stick with something we're really familiar with. These two things are exactly the same, right? Exactly. So if I write it as a fraction, 1 foot over 12 inches, what does this fraction equal if they are the same? 1, right? So this fraction equals 1. Any conversion factor you have is supposed to have an equivalency on the numerator and denominator. So it doesn't change the value. It doesn't change the actual measurement. It just changes the way we display it. So instead of me saying 1 foot, I'm going to say 12 inches. It looks like I changed the measurement, but I didn't, because they're literally the same measurement. I've just changed the way it looks, the unit. So that's all a conversion factor is. And so this is kind of a little bit more like textbook definition. Fractions made from measurements that have fractional units from equivalencies or from equivalence. Just saying they're the same, equivalencies, top and bottom. When you divide something that's the same by itself, it is 1. Even if it looks different, it's still 1. Some units that we're going to see today and later on are things called moles. Grams per mole or grams per milliliter. Those are just other fractional units that we've been exposed to. This one right here is going to help us with something called molar mass once we get into the talking about more about chemicals. This one, what unit does this display? Yeah, so this is milliliters, grams per milliliter though. That total fractional unit is what am I talking about if I say grams per milliliter? Density, right? So density, I'm saying that, 1 gram of water is equal to, if I put it in a graduated cylinder, is equal to 1 milliliter of water. So I'm saying they're equivalent. Even though grams and milliliters are not the same, 1 gram of water equals 1 milliliter of water. So that's also an equivalency, and that's a conversion factor we can use. Density is a really good tool for that. Some of the examples that we're going to be using a lot today are related to our number line. So you remember this right here? King Henry died by drinking chocolate milk, ... what is this one? Micro, ... nano, ... pico, right? So we're going to use our number line a bit today, and I showed you in the YouTube note how you could swoosh the decimal over left and right. That's the cheap way of doing it. The reason I want to kind of start using dimensional analysis for those things that we can do swooping on is because in the future you're not going to even know what the units are. You're not going to be able to just do the swoop method. So I'm trying to give you some tools that you can use. So don't forget that base is going to be our meters, grams, or liters. And then as we go left and right, we're going to be changing up the zeros, the size of the scale of the unit. So you'll see here, I chose to assign between kilograms and grams. Between those two units, which of those is the larger unit? Kilograms, right? So what I did was I just said, okay, 1 kilogram. This right here, this pink writing right here, I always reference the larger unit, and I say I have 1 of those, because I think this is the easiest way to do it. So I have 1 kilogram. And if I wanted to see how many little bitty grams fit in a big kilogram, I just mark off the zeros that get me to base, which is gram here. So I have 1, and then I have a 0, and a 0. That's going to get me over to base, which is my gram. So I have to see how many, hundreds, millions, trillions of whatever I need to make it equal to 1 kilogram. So I assign the larger unit as 1, and then I find the equivalency of the other. This means I need 1,000 grams to equal 1 kilogram. That's how I got this. So this equivalency, 1 kilogram is equal to 1,000 grams, and I just usually prefer to write in scientific method because it actually makes me do less work. So let's do another one just like that. I want to see the equivalency between grams and micrometer, or grams and micrograms. Grams and micrograms. So which one of these do I assign to be the 1? The gram or the microgram? Gram, it's the larger number or larger unit. So right here I'm going to assign a 1. So 1 gram is equal to, and then how many zeros do I put here to get over to micro? 6, right? So 1, 2, 3. These dots do count. 4, 5, and then 6. So 1 gram is equal to 10 to the 6 micrograms. So we're going to do that a bit today. And these other ones we'll get to as well. Okay, so let's do a practice one. I'm going to do a lot of practices with you. Once you get the hang of it, please let me know, because I don't want to kill you to death with practice problems, because my goal is to do this about 30, 40 minutes, and then you guys do your homework and ask me questions as you go, okay, because the homework's going to have a lot of this on it. All right, so this is going to be an example problem. So we have given to us the density of aluminum, 2.7 grams per centimeter cubed. This could also be written as 2.7 grams per milliliter, because like I said last week, we can interchange centimeters cubed and milliliters because the density of water is 1 gram per milliliter, 1 gram per 1 milliliter. They're interchangeable. So don't be scared. Don't be scared if you see one or the other. You can always change it to whatever you want. In this case, our question is 40.0 centimeters cubed of aluminum is equivalent to how many grams? So what am I looking for? What unit? What's my question? Grams, right? So my question is grams. I want to get to grams in the end. And this is how I was taught to do it, and I think it's great because I can never forget what I'm asked of. I always write down what I'm asked of, and then I write down my first given. My given is the first fact that's given to me in the problem. So I always write down my question, and then I want to start with my given, and then I'm going to use the conversion factors given to me either on paper or, I naturally know some of these conversion factors like the metric stuff we were just given. And then I'm going to get to my final answer. So I know my given is grams. I know I'm going to start with 40.0 centimeters cubed. And then I'm going to multiply across the board to get rid of centimeters cubed. So I'm going to multiply by something with, how do I get rid of centimeters cubed? Does it go on the top or on the bottom of a fraction? Right, the bottom, right? So I want centimeters cubed down here. And I'm only given one conversion factor. Like there's no question about what I'm going to use. I'm going to use that conversion factor given to me, and I'm going to write it just as it is. 2.7 grams per centimeter cubed. So I'm going to put the 2.7 grams on top because that 2.7, it's attached to the grams. You cannot separate them. They go together. Per, how many centimeters are down here? 1, because it doesn't say 1, but you can assume it's 1. So 1 centimeter cubed. All right, so what units can cancel? Yeah, centimeters cubed on top and bottom, because anything that's on top and the bottom you can cancel. That leaves us with what unit? Grams is the only unit left. Bada bing, bada boom, we got it. We got grams. Okay, now we just have to actually calculate. So across, in your, if you all have your calculators out, just type in 40.0 times 2.7. You don't have to divide by 1 because dividing by 1 is, you do it in your head. And tell me exactly what you get, and then we will round to sig figs. 108, okay. 108 grams, right? Okay, this is where in the back of your head you're going, oh, she's going to look for sig figs. How many sig figs in this first number? 3 sig figs, right? And this is because you said decimal present, start from the Pacific, and then 1, 2, 3. How many sig figs here? 2 sig figs. Who wins? Who's the weakest link? 2. So I need to round this to 2 sig figs, right? The rounding process is really simple. You start from the left. You underline the 2 you absolutely need. You need the 1 and the 0. But then you have to estimate. Does this 8 influence that 0? Yes, so it's going to round up to what? 110 grams. Noticing that I only have 2 sig figs, which are the 1 and the 1. The 0 is not significant because there's no decimal afterwards. If I did put a decimal afterwards, it would be 3 sig figs because I'm saying I'm exactly 100% sure it's 110. Exactly. This is like, I'm sure it's 100, about 110. It's actually 108. All right, so it wasn't too bad, right? Just canceling units. And I just want to go through a couple more complex examples. So look at these units. Kilojoules per mole, grams per mole, joules per calories, molecules and moles. Things that it doesn't matter what I give you. As long as you understand that you need to cancel out units, you're awesome, you're good. I can give you ponies, dinosaurs, and rainbows. It doesn't matter. As long as you can cancel those units, like, I don't know, 1 pony is equal to 1 rainbow. If I told you that was the equivalency, you just have to cancel the units. It's all about the units. So this is all information about water. You don't even have to understand what these units are. We're going to call them dinosaurs and ponies. We just need to look at our question and get to the point where we're getting to the unit that's asked of us. So I'm going to start with question. I need moles. That's my desired unit. What's my given? Yeah, this is my given because it's the fact that's given to me. So all of these up here are all conversion factors. They can be used to cancel units if we need to. And we definitely want to. We want to get out of grams, and we want to get 2 moles. So do you see any conversion factor up here that has the 2 units you're using? The gram that you have to start with and the mole that you want. Which one? Yes, molar mass. Good. So this one right here, that 18.02 grams per mole, that's one you want. So I can give you a big chart like this. You don't have to even understand what the units are. We eventually will, but right now you don't have to. And you can just say, oh, I have grams and I want to get rid of them. Okay? And I want moles, so I have to use this one. The only thing that's different, though, is when I write this down, what unit needs to go on bottom? Grams. Okay, what number is associated with grams in that conversion factor? So right, the 18.02 stays with the gram. You don't get to separate. And what number is associated with the moles? Right, 1. So that's 1 mole. So you're just writing it down in a way that allows you to cancel out stuff you don't want. In the numerator, you should always have the thing you do want, that unit you do want. So I just flipped that. That's all I did. It's a fraction. I can do what I want with it. I can flip it. So grams and grams cancel. So then in your calculator, what are you going to do? So 40.0 divided by 18.2 or 02, or 40.0 times 1 over 18.2 if you want to do it as a fraction. However you want to, as long as you use your parentheses if you're doing fractions, your calculator will understand what you want to do. Anybody?
You want the fraction or the decimal?
I want, give me the decimal.
All right, 2.219.
That's good. That's a 9 right there, by the way. Okay, so that's moles, because that's the unit that I had left. How many sig figs in the first number? 3 sig figs. This one? 4 sig figs. So who's my weakest link? 3. So I need to round this to 3 sig figs, yeah? So I'm going to take the first 3, 2.21, and I have to write down the rounded version. So does this 9 influence the 1? Yes. So that final answer is 2.2. That 1 rounds up to 2 moles. So you can see that I'm not changing the entire number when I'm rounding. I'm just truncating it short of all the sig figs that are currently listed. All right, so that one wasn't too bad. Let's do another one where we have maybe not only one fraction, we have 2 fractions with the right. Okay, so write down your question as molecules. And our given is 80.4 milliliters. So I have to scroll back up to the top so you guys can see all the conversions. All right, so 80.4 milliliters. So we want to look and see if there's anything with a direct comparison between milliliters and molecules. All right. Do you see anything with a direct comparison between milliliters and molecules? Milliliters and molecules in the same number. That's moles and molecules, right?
Oh, so you
Right?
change it to moles and then change it to moles.
That very well might be true, right? We might have to do one more thing. So we know we're going to have to eventually use this one because that's the only one with molecules in it. But I'm going to save that one for last because I want to get the molecules as my very last conversion because that's what my final answer is. So it means I had to have gotten to moles first. But what am I starting with? What's my given? Milliliters. Okay, do you see anything with milliliters and moles? Density doesn't have milliliters and moles, it's got grams and milliliters, right? But that's the only thing with milliliters in it, right? So you know you have to use this one. So we know we're going to have to use that one first because my very starting quantity is in milliliters, right? So it's like a puzzle. You have to put it together. So we know we're going to use that one first because that has milliliters in it. But this milliliters conversion is going to get us to grams. I don't want grams. I wanted to get to moles so I could get to molecules. So I need to do something with grams and moles in it together. Molar mass. All right, so I'm going to go from milliliters to grams, grams to moles, moles to molecules. That one's a bit more complicated because we have 3 steps to take, but it's baby steps. So let's go baby steps at a time and let's do this together. I'm going to give myself a page here. Hopefully you guys can still see that a little bit here. And I can tell you the numbers. So the first thing I'm writing is 80.4 milliliters. And so I need to cancel out what? Milliliters. So I'm going to put it on the bottom. And you told me the only thing with milliliters in it was, it's hard to see that number. This first one up here, milliliters, and then the quantity is 0.9994 grams. So I'm going to put 1 milliliter is equivalent to 0.994 grams. What unit has canceled thus far? Milliliters. Great. Okay, so my next conversion is going to need to cancel what unit? Yeah, so you just keep going. I'm going to keep going here just so we have one big calculation in the end. You know I don't want grams. Nobody cares about grams. I want molecules in the end. So I need to take the gram that is here in the numerator. I need to bring it down here. I need to figure out what conversion factor you guys just told me to use for that. Which was that? Right, the molar mass one. So it says 18.02 grams per mole, 1 mole, per 1 mole. So the 18.02 grams goes with the gram. You don't get to separate them. And the mole is actually going to go on top. So I just flip this fraction to do what I want it to. I want to flip it because I need to have something to cancel out grams from this one to eventually allow me to get to my final answer. So I'm still not there. So you'll see the first number you write guides you as you continue on. So I'm guiding myself to figure out the next part. I see I have moles here. Did I have something that got me from moles to molecules? Yeah, I did. I had this very last one. It's hard to see. 1 mole is 6.02 times 10 to the 23rd molecules. That big number goes with molecules. So I'm going to kind of continue down here. Knowing I need to get rid of moles, it's going to go in the denominator. What number is associated with mole? Oh, sorry, there's a 1 in front. You guys can barely see this number. I'm sorry. That's 1 mole. And then this number, 6.02 times 10 to the 23 molecules, that's going to go on top. And then what unit cancels? Moles, right. So the moles from this numerator and this denominator are able to cancel. What's the only unit left that I've not canceled? The last one, right? Molecules. And that was what my question was molecules, right? So that was actually a really rough one. But it's no question about what's guiding you. Whatever unit you write and you don't want it, you have to put it in the denominator. But these conversion factors, they're not, I'm just not pulling them out of the air. They're going to be given to you in a problem usually. So you always have to kind of check yourself and go, okay, I want to cancel this one, what's the next one? Can I cancel it? Yeah, I can. Can I cancel it? Yeah, I can. And continue. So when you get here, I have that for you. 2.68 times 10 to the 24 molecules. And how many sig figs throughout the problem, or which was my limiting number of sig figs? Who was my weakest link? Yeah, 3 sig figs, because I see this one only has 3 sig figs, and this one only has 3 sig figs, and both of those are my weakest links. Yes, ma'am. Because that's my calculator said, first of all, but I did 80 times the 0.99, which is going to be about 1 still, so it's still about 80, divided by 18 is going to be a number greater than, let's see, that's like what, 20, no, that's 4, and 4 times 6 is 24, which brings my decimal over 1, so I could write it as a number between 1 and 10. So, it's just putting your calculator. Okay. Right. Give me a 1 out of 10. Do you see the units? You see that that's the only really thing that's important. All right, thank you. Anybody else? Yeah? All right, some of us are not going to answer because I think we want to do a couple more here. Okay. I'm going to go through ones that are on your lecture sheet though. Oh, no, I want single display. I'm going to skip those for now. All right, do you see on your student sheet it says factor label method, dimensional analysis practice, problems, one-step conversions. All right, so if you just write like a heading on your notebook paper as this, you don't have to write down all these questions. I have the questions there, and it's just in case I move up or something and you guys need it, okay? So we're going to show some work together. And I might just do like 2 from each problem, or 3 from each step segments here, because I just want to make sure you have a good example for yourself. Okay, so one-step conversions, the base unit is what you're looking for, or it's what you're starting with. The base units are going to be referring to what I'm talking about over here on the base unit, meters, grams, and meters. So this is what we're going to use that number line a lot, okay? So if you need to write that down, write that down. I'll make it this way so it's not confusing. All right, so my question is grams, right? I'm starting with what? 3,500.0 milligrams. I need to get rid of what unit? You want to get rid of the milligrams, right? So you have to put milligrams in the bottom. Are you able to directly convert from milligrams to grams? Yay or nay? Yay, because you got the whole number line to work with. This is anything that's got millis, kilo, nano, that's all just metric stuff. If it's metric stuff, you got the number line to work with, and we're good. So yeah, you can definitely go from milligrams to grams. And this is where we're going to go back to reference the larger unit as 1 and then write the equivalency of the other units. Which of those units is greater? Gram. So I'm going to give the gram the 1, and then I go to the number line, and I say, okay, how many milligrams are in a gram? Here's my gram as 1, it's the base unit. And then I bounce over to the milli, which is this one. 1, 2, 3. So how many milligrams are in a gram? 1,000, or 10 to the third, right? Milligrams. And I'm not going to write out these zeros every time. I want you guys to kind of start visualizing it here, or write it on your own paper and try, okay? So this is 1,000 milligrams, or I could put 10 to the third. That's it. I'm done. I got the grams I wanted, and I just go ahead and calculate here. So 3,500.0 divided by 1,000 is going to be, thank you. But I need to understand that, I know you guys don't want these caveats, but there's a caveat here. For the metric stuff, the only number I'm concerned about that's a true measurement that really concerns my sig figs is the first one given to me. So metric stuff, I want you to go and convert, round to the sig figs given to you in the problem itself. So how many sig figs here? 5 sig figs, okay? So what do I need here to make sure I've got my 5 sig figs? Bunch of zeros. 1, 2, 3. Okay. So I'm saying it is exactly 3.5000 grams. That is my final answer. All right. You could have just done your decimal sweeps, I know. Abstract 3 and did it. But I'm trying to give you some familiar practice before we get to the unfamiliar practice. All right, let's do number 3. Convert micrometers to meters. So my question is meters. My given is 84345.6 micrometers. What do I need to cancel? Right, the micro, right? I need to cancel the micro. Can I directly go from micro to base unit meters? Yeah, I have a number line to work with, right? So I'm going to put meter on top. And then I go back and I go, okay, which of these is my larger unit? Right, the meter is my larger unit. I assign a 1 to the meter. How many micros are in 1 meter? Give me a scientific notation. 10 to the 6. Look, this is milli. This is micro. So no, remember those dots are placeholders. They actually have unit names, but nobody cares about those unit names, so I don't have to reference them. So if my base is 1 meter, like I have over there, I have to go 1, 2, 3. This dot counts 4. This dot counts 5, and the micro 6. So that's 10 to the 6th. 1 gram is equal to 10 to the 6th micrometers. I have to make sure I don't look at the milli because people always look at milli for micro. And I'm lazy. I'm not going to write 1 with 6 zeros. I'm going to write 10 to the 6th because I can put that in my calculator pretty easy too. So when I convert, and the only reason I'm converting now is because micrometers and micrometers cancel. I get meters, which I wanted. Great. So 8.4345.6 divided by 10 to the 6th. That's going to be, if you put in your calculator, 0.0843456 meters. Yeah. Looking at sig figs in the very beginning, how many sig figs were given? 6, right? Because you see the 1, 2, 3, 4, 5, 6. And then how many sig figs are here? 6. Because I started the decimal. I don't start counting at that 0 because it's not a non-zero digit. And then 1, 2, 3, 4, 5, 6. So I know you don't want to write that huge number, but that's very accurate. We have lots of sig figs, so that's good. All right, thumbs up if this is good. 1-steppers. 1-steppers. All right, most of us are good on 1-steppers. Let's do some 2-steppers then. Actually, let's do some mixed units, and I'll go to 2-steppers. 5 or 6, which one do you guys want to do? 6, okay. You'll see that we have now fractional units, so we have something in numerator and denominator we have to be concerned about. So look at I'm just going to look at units first. I have grams that want to go to kilograms. I can do that. And I have milliliters that want to go to liters. I can do that. So we're going to do two kind of separate thoughts here to do both of those conversions. So I'm going to start with my 4.52 grams per milliliter. And instead of writing as a slash, I'm writing as like a full fraction, so you can see the units and see the difference between numerator and denominator. And you'll never see me write like a slash in the dimensional analysis solving problem. All right, so which of these are we going to do first? You want to do the grams to kilograms first? Is that fine? All right, let's just start with the numerator. So I want to get from grams to kilograms. I know my grams have to go on the bottom because I have to cancel them. What unit has to go on top? Kilograms. Okay, which of those units is bigger? Kilograms. So the one goes to the kilograms. How many little bitty grams are in a kilogram? I heard it say again? 10 to the third or 1,000, right? Because you have a kilogram, which would be the one, and then 0, 0, 0, you go over the base, which is grams. So get 10 to the third or 1,000. So I'm just writing both ways here. So great, yeah. About one down, one to go. So grams and grams are gone. I need to keep this kilo because that's what I told myself I need to get. So don't mess with the kilogram anymore. What unit do we want to get rid of now? Milliliter. So I need to take the milliliter, and to cancel it from the denominator, I have to put it where? Right up top, milliliter on top. And so that's going to cancel me from even though I'm one apart, it doesn't matter. It's denominator down here, numerator up there. I'll cancel that in a second. I want to get from milli to liter. So I need to put a liter in the bottom. Which is larger? Liter. How many millis are in a liter? 1,000 or 10 to the third, right? I'm actually going to write it as 1,000 here too. I'll show you why. 1,000 milliliters in a liter. Okay, cool. So now I'm able to say, okay, milliliters are gone and gone because there's one in the denominator and the numerator. And the units that are staying are kilograms and liters, which is what the question asked of me. So in this problem, you don't have to do much math. You'll notice that we have 1,000 in the denominator and 1,000 in the numerator. Those negate each other, right? All right, so that's just me looking at easy math. So what's the answer? 4.52 kilograms per liter. So I don't actually have to plug in my calculator if I look and kind of cheat and say, oh, thousands and thousands cancel. So that was a little bit more in depth because we had 2 units to deal with. Sig figs in this case are just dealing with your first number given to you, so 3. Moving on. Yeah. If you saw that in the very beginning, I'd be cool with that because I can see you going, okay, 1,000 more and 1,000 more. I'm cool with that. But if I want you to show your work for something like this, I'm just getting you to the point where you can do it with unknown units. Not every unit's going to have like a metric thing associated with it. So this is just like a practice with known things. Eventually we'll get to practices with unknown things. Okay, so we're going to keep going through, but these are going to be actually, and we already did a 2 separate. I'm just going to do one of these. I'm going to do number 3. Okay, I'm going to go with number 3 because I think we already did one of these and it was a really hard one, so I think we're okay. So you'll notice I'm starting with kiloliters, I'm going to milliliters. This doesn't have to be a 2-stepper, this can be a 1-stepper, and I'll show you both ways. My given is 0.00674 kiloliters. If you were smart and you're like, oh, I can do this, can I do 1 step from kiloliters to milliliters? Do I have to stop at base in the middle? No, I can keep stretching those zeros all the way across. And that would be what I expect you guys to do because you're smart. I mean, you're good at math, you're in honors chemistry. I believe in you, okay? So I'm going to drop my kiloliter down here to the denominator. I want to go straight to milliliters. Which of those is larger? Kiloliter, right? How many milliliters are in a kiloliter? 10 to the 6th. So you went 1 kilo, and then 1, 2, 3, 4, 5, 6, because milli is M. So yeah, 1 kiloliter is 10 to the 6th milliliters. So I'm not going to have you guys do that in 2 steps. If you get that, you're awesome. Some people feel like they have to stop at base and go, okay, let's restart base and then to the next smaller unit. And that's okay if that's what you got to do, kind of keep your brain organized. I'm going to do it like this though. So blah, 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 times 10 to the 6th is equal to 6.74 times 10 to the What'd you say?
Oh, okay. No, no.
So you're moving because you're going 10 to the third milliliters? 10 to the third? Okay, thank you. Alrighty. You could do that in 2 steps if you wanted to. I'm not going to do another one of these though because it's very similar to number 1. If I can, yeah, we're all good here. Alright, so these are the ones that people get a little bit more confused on because we have units that are of exponents. So I'm going to do 1 or 2 of these, and you guys let me know when we're good here. So you'll notice we have cubed and squared throughout the problem here. So let's go ahead and start with the first one. Meters cubed to centimeters cubed. So my question is centimeters cubed. The trick here is if you cube one thing like a unit, go ahead and cube the whole shebang. Like cube the number and everything that you're converting with. Don't cube this number. This number is told as is. 800.4 meters cubed. Okay? And I want to get out of meters cubed. So what has to go in the denominator? Meters cubed. I want to get 2 centimeters cubed. So it has to go on top. So ignoring the cube and cube thing for a second. Ignore it. If you just had to tell me in 1 meter, sorry, I'm telling you 1 meter is going to go with the with the meter because it's the larger unit, right? How many centimeters are in 1 meter? Look at your number line. 100, right? Because it's only 2 decimals over. So 1 of these, 0, 0 to centi, so it'll be 100 centimeters. So 1 meter is equal to 100 centimeters. If I cube this to be meters cubed, I have to cube this to be centimeters cubed. But when I cube a 1, it's still a 1, right? But when I cube 100, it's 10 to the 6. It's 100, which is 10 squared cubed. What do you do with the exponents? Multiply them, so that's 10 to the 6. So I'm not always going to write it like this, because I can let my calculator do a lot of the work for me. So right here, I'm just going to write 10, no, I'm going to write 100 like I just had. And I'm just going to cube it, because that's what my unit is doing. And I'm going to write the 1 just like I had, and I'm going to cube it just like my unit is doing. So whatever my unit has in terms of an exponent, my number associated with it also needs that. Because I could just go ahead and write it like this, but I just already had those units there. So you could write it just like this, cancel meters cubed, cancels meters cubed, and then say to yourself, all right, 800.4 times 100, which is cubed, and then tell me the answer. Or that would be 10 to the 6. So 8.004 times 10 to the 8. I did that right? You guys can check from your calculator. That is okay. All right, and then how many sig figs in the first number? 4 sig figs here, so I had 4 sig figs there. And like I told you guys last week, I love scientific notation because all my sig figs go in the front, and I can never really mess up. Because if I wrote out 8,004, 0,000,000, whatever numbers, it's harder to see your sig figs there. So I like to write like that. All right, and then centimeters cubed 6. Let's do one more. 88.46 meters squared times, what unit goes on bottom? Meters squared. Kilometers squared is going to go up top. All right, so, over to the side of your paper or in your head, you're going, all right, which of those is a larger unit? Yeah, right, kilometers or kilometers, right? That is larger, so I'm going to give it a 1, is equal to how many meters? 1,000, right? Because it's 3 zeros over. So 10 to the 3rd over. But then I have to do what it says. If it says squared, I have to square it. So this will be squared, this will be squared, 10 to the 3rd will be squared, and meters will be squared. So here, I'm just going to write, I can put 1,000 right here and square it, or I can put 10 to the 3rd like I just had there and square it. I'm just giving you options, so, you can pick whatever floats your boat there. So in your calculator, you're going to do, unit cancel, right? So meter squared cancels, meter squared cancels. And then my final answer will be 88.46 times 1,000 squared. So that'd be 6 decimals that way. So it would be 80 or 8.846 times 10 to the 7th kilometers squared. Nope. Oh, you know what? I just realized I did that. Rewind 30 seconds. I'm sorry. Going from here to here, I wrote the numbers flip-flop. So give me a second, I'll fix this because I was like, that's supposed to be a smaller number and it's a larger number. Let me just rewrite what we just had. We had meters squared down here and kilometers squared up here. The 1 is supposed to go up top with the kilometers, and the 10 to the 3rd squared or 10 to the 6th or 1,000 squared, however you want to write it, goes in the denominator. So I'm going to put 10 to the 3rd squared like I have right here, which would give me that divided by, 88.46 divided by 10 to the 6th, which would be a negative. When you write it in scientific notation, you have to write your exponent as negative to give yourself your swooshing to the left. So it'll be 10 to the negative 5th. Or if you're really liking those decimals, 0.0008846 kilometers squared. I just think that's a little more tedious. All right, let's get to some good stuff. Let's get to like a little bit more complex. I want to do one on your problem set. Can we do that? Actually, no, I lied. Let's do the ones on the bottom of your sheet. Your sheet has like, we did some squared and we did some complex earlier. I'll do another one if we need to. Then you see mixed 1 through 8. I'm going to go down to 10 through 15. Let's do maybe 2 of those word problems, because so far I've just been throwing up there like, here's your given, here's your unknown, or your question. These are kind of embedded in word problem form. So let's just do one. All right, I'm starting with 10 first, and then we'll move on to another one. And then I'll leave you alone and let you guys do homework. So, looking at number 10, the density of lead is 11.3 grams per milliliter. What is the mass of 45 milliliters of a metal? All right, so what is the conversion factor that's given to us just in plain sight right here? Right, so we're given density is 11.3 grams per milliliter. And I like to write that down as itself, because who wants to go back and read a word problem 5 times? Because if it's maybe a five sentence word problem, you're going to be reading that thing for like 20 minutes every time you go back and read. So that's a conversion factor for myself. All right, what's the given to me? What's the fact? In the problem, it says, what is the mass of 45 milliliters of a metal? 45. It's the only thing I'm given, right? So the first, and this is going to be the first step of my problem. I'm given 45 milliliters, which is volume. It's sometimes nice to label what it is, too, because if it's a formula that you just need to see the variables in your head and you write them out, you can see them a lot better. What's the question here? What am I looking for? Mass, right? So my question is mass. And in your head, you're going, oh, that means grams. I'm looking for grams. All right, so you see the word problems are not, you got to read between the lines on what you're looking for. So you're given a conversion factor in plain sight. It says, density, 11.3 grams per milliliter. You're given volume or milliliters to start with, and they ask for mass. All right, so what am I starting with? What's my fact I'm starting with? Right, 45 milliliters multiplied by, because I'm going to solve this via dimensional analysis, multiplied by something that allows me to cancel milliliters. But what's the only fractional units they give me? All right, they give me this density here. And I'm going to write it exactly as is because I need those milliliters in the bottom. Milliliters here. The 11.3 grams are going to go on top as the units, it says itself. Milliliters cancel. And I get to grams. 508.5 grams. All right, is that my final answer? All right, how many sig figs do I need? 2, because I can see this one's my limiting. I have 2 sig figs here, 3 sig figs here. All right, so this one needs to be rounded to 2 sig figs. So I need these first 2 to stay, but I still need to be 500 something. So can I use this 8 to round up or down? Up, right? So I take that and say that's 5. That 0 goes up to 1, but I still need to put a 0 here to indicate the placeholder. So it's 510 grams would be the best answer here. All right, so that's a density related one. Let's do one that's not as familiar. Let's do a hard one. Let's do number 14. 14. So as I read, I'm going to kind of show you how I do the problem. I'm going to go through and write down my givens like I was just doing. How much heat? Is that a question? How much heat? That sounds like a question, right? All right, so my goal is to say how much heat is given off. What is the unit for heat? You saw this in your reading guide. Saw a couple times. Kelvin is going to be temperature. Heat and temperature are actually two different things that are really related, though. It was joules. Remember that? It was a J. You may have remembered. Okay. Anyway, this is going to be heat. So the question is, how many joules is given off when water condenses? I'm sorry, it doesn't ask for how many joules. I'm just making up stuff, guys. That's not actually a complete sentence. The amount, 14, let me start. The amount of heat given off when water condenses is 254 kilojoules per mole. I was making up stuff. The amount of heat given off is 254 kilojoules, so just kilo, like our metric stuff over there, per mole. That's a fractional conversion factor given to us in the problem. The molecular weight of water is, you see, like, I can say dinosaurs and ponies, but when you see a number, that's what you're concerned about. The molecular weight of water is 18.0 grams per mole. All right, so notice now I have two conversion factors. So both the fractional things we've been dealing with all day. Question, how much heat, so now I've got my question, how much heat in kilojoules, because it tells you in parentheses, is given off when 15 grams of water, 15.0, excuse me, grams of water condenses. Okay, so I've got 4 pieces of information. And I'm going to scratch, you don't have to write water, I'm going to scratch it because I didn't write water anywhere else. It was kilojoules per mole of water, but I'm going to go with what we have here. Everything's water related. So we have a fact, we have a conversion factor, another conversion factor, and our question. So what do I have to start with? Right, I have to start with the given of 15 grams. And notice that, and my next step is going to be convert, but what's the only thing I can use? There's only one thing I can use that makes sense. Right, the 18.0 grams per mole one, because that's the only one with what in it? Grams, right? I want to get rid of grams. Nobody cares about grams. I care about kilojoules. That's what I want. So to get rid of grams, I have to find the conversion factor with grams in it. Well, there was only one. Grams goes on bottom to cancel. What number is associated with the gram up there? 18.0. And then the mole has a 1 associated with it, so we'll have 1 mole on top. Okay, 1 down, 2 to go. So grams and grams cancel. Now, you'll notice I still want kilojoules. I'm at moles so far. What's my next step that would get me to get out of moles into kilojoules? This big one right here, right? So the 254 kilojoules per mole. Do I write it as is or do I flip it? As is, because I want the mole in the denominator down here, because I need moles to cancel. So the 1 mole from here goes down here, and then the 254 kilojoules goes in the numerator. Okay, so we've used both conversion factors. I used my given and my desired unit. What do I want? Kilojoules. I'm in kilojoules, right? Because these moles and moles cancel. The only unit left is what I wanted, which was kilojoules. So in my calculator, I'll do 15 times 254 divided by 18, or 15 times parentheses 1 over 18 times 254. It depends on how you want to use your calculator, if you like parentheses or not. So everything in the denominator divided by everything in the everything in the numerator divided by everything in the denominator, and you get 211.667 kilojoules. How many sig figs do I want? How many? 3, because everything has 3. 3 here, 3 here, 3 here. So I really don't have a question about what I need. I need 3. Round that for me. Right, 212, because the 6 affects the 1 to round up. 212 kilojoules. That was a harder one, because, I mean, at this point in our life, we're not masters in chemistry. We barely know. We don't know what a joule is. We don't know what a gram per mole even means really right now. You know, so I can give you stuff you don't, you know, you're not a master on, but you can look at the units and cancel. You guys just did that, okay? So, do me a favor. We have about 40 minutes left about. Go ahead and finish the word problems on this. The ones we just worked on, I did 2 of them. You have 4 left. And then you guys can start on problem set 3B, and I can pull up on the board and let you print it and have it yourself, okay? So problem set 3B, show all working units, that's your homework. So I'm giving you this time right now to ask me questions and answer anything that I didn't answer for you. So if you're not one to go, Miss Imla, I need you to do that again, now's that time for us to work together, okay? And you guys can work together on this. If music helps you, as long as I see you working the whole time, I'm good with that too. Yeah, you're only doing on the rest of the lecture notes, you're only doing the word problems, which were numbers 11, 12, 13, and 15. So these are the ones I want you to do. If I can do some of them with you, that's fine. I can do those. And you guys can start your problem set homework.